Now here we have a question. Calculate the standard cell potential in volts. Calculate the standard cell potential in volts of a cell which following reaction takes place. So they have given the cell Fe2 plus in aqueous solution reacted with Ag plus in aqueous solution gives Fe plus 3 and Ag solid. So given that the electrode potential, standard electrode potential of Ag plus is X volt and electrode potential of iron plus 2 is Y volt. Similarly, they have given ferric to ferrous electrode potential given as Z volt. Then the standard cell potential of this reaction is, this is actually a previous year question, okay now in JEE Mains. Now have a look on the solution, how to solve this kind of questions. So I'm writing, I have given this complete reaction. Okay, now once again I wrote the complete given reaction, that is Fe plus 2 treated with Ag plus gives rise to Fe plus 3 and Ag solid. So in this reaction you may observe I have sorted this complete equation. I have divided this complete equation into two parts. One is oxidation half reaction, another one is reduction half reaction. You can observe here I have given with a different symbols. So with box I have separated Fe plus 2 to Fe plus 3. We know that oxidation reaction, and Ag plus 2 Ag is a reduction reaction. So after sort out this reduction of oxidation reaction, now I am writing the standard cell potential formula. We know that formula is E cathode minus E anode. That means the reduction reaction takes place at cathode minus the oxidation reduction takes place at anode potential. So E cathode minus E anode. Clear? So now according to the data I am calculating by substituting in this formula. So E naught cell equal to the E cathode means electrode potential at a cathode. So electrode potential at cathode, here electrode potential at cathode is, according to the equation, cathode reaction is reduction reaction. We know that according to the Daniell cell, always the reduction reaction takes place at a cathode. So the reduction reaction takes place at cathode. So at cathode, the electrode potential is X volts. I have substituted here X volts. Clear? X volts. You can observe here X volts. I will substitute here X volts. Clear? X volts minus E naught of anodic reaction Fe plus 3 to Fe2 plus. But as per the given data, Fe3 plus 2 Fe2 plus is not given. You can observe here. But instead of that, they have given a set of reactions which can obtain iron from Fe plus 2, which can obtain iron from Fe plus 3 as Y volts and Z volts respectively. So in order to calculate this iron plus 3 to iron 2 plus, we have to take that two half cells data. Accordingly that we have to calculate the E naught of that complete cell. So according to the data they have given iron plus 2 to iron, that potential they have given is that E1 naught. I am assuming the given is Y volts. Clear? Simply I am writing that in complete equation format. No need to worry about that. You can write directly also, no issue. So another cell they have given as Fe plus 3 to Fe, and that is assumed as E2 naught. So given as per the data Z volts. So by using this E1 naught and E2 naught, we have to calculate E3 naught. We have to calculate E3 naught. What is meaning by E3 naught here? In the given, expect the reaction Fe plus 3 to Fe plus 2. So we don't know that what is the potential. So by using these above two equations, we have to calculate E3 naught. So we know that E3 naught cannot be calculated direct by using from this equation. So by using Gibbs energy change, we can calculate. We know that Gibbs energy is an extensive property, right? So therefore we are using in this equation delta G. We are calculating delta G for this equation. So Gibbs energy change, we know that formula delta G equal to minus NF E naught cell right? So where N is valency, F is Faraday, and E naught cell is the electrode potential of that cell. So therefore, as per this equation, here the charge is 2 plus. Okay now. So therefore, N is I have taken as valency 2 and F as usually E1 naught. We can substitute here also directly. Okay now, E1 naught as Y volts. So we will substitute in the end of the stage. That will be easy for the calculation. So therefore, minus 2F E naught. Similarly, for this reaction, Gibbs energy change will be 3F E2 naught. Clear. So for that, complete cell reaction Fe plus 3 to Fe plus 2. Here we have to calculate. For this Gibbs energy is once again here the change in oxidation number is, that means how many electrons? 1 electron. So therefore N equal to 1, right? You may take here 1 and F into E3 naught. So therefore, as per the extensive property, we can calculate the complete half cell reaction is the difference between the Gibbs energies. So therefore delta G3 naught equal to delta G2 naught minus delta G1 naught. So I'm substituting these values, and after simplifying, I'm getting as minus E3 naught equal to 3E2 naught plus 2E1 naught. So here upon simplifying, upon substituting, whereas E2 naught Z, whereas E1 naught as Y. So upon simplifying, I am getting E3 naught is 3Z minus 2Y. Now this E3 naught I am substituting in the equation 1. Right, that is nothing but the first equation which we have to calculate. E naught cell is equal to E cathode minus E anode. In that I am substituting. E cathode is X volts. Right, E anode is just now we have calculated for the Fe plus 3 to Fe as 3Z minus 2Y. So simplified here, and we have got the answer X plus 2Y minus 3Z. Therefore option A is correct.